All right. Oops, wrong layer. Okay, so we're going to be doing Math 127. We're going to be doing trigs. Trig functions of real numbers. We won't get into anything else in this class, so it'll always be real numbers. All right, so let t be any real number and px be the terminal point. And in a circle, we define the following. So sine of t is the y value, cosine of t is the x value. From there, we're going to build up the rest of them. Cosecant is 1 over y. Secant is 1 over x. Tangent is y over x, and then cotangent is x over y. We'll redo this all next time. I think after we do chapter 5 and you do that, I do like the first 4 sections because we just rebuild all of this with right triangles. And I don't think we need to spend 4 sections doing that. But so there'll be shorter notes. All right, so let's talk about domains. So the domain of sine and cosine is all real numbers. The domains of tangent and secant are all real numbers other than square root 2 over 2 plus n pi, and cotangent and cosecant are all real numbers except for n pi. Why do I have to throw away these numbers for sine or for cosecant and cotangent? Why do I throw away these numbers for these? Does anyone know? Anyone have a guess? 0, yeah. So 0 can't be in the denominator. That's correct. So here, notice here when t is pi, I'm right here. When t is pi, my y value is 0. So this can't be 0, and this can't be 0. Okay. So yes, so that's exactly why. So that's why we had to throw away these away for domains. For those who did 126 here at UNLV, we know we do domain. Domain is a big thing for the 126 questions. Here we're talking about which functions are positive, which ones are negative. This is because of the x and y values. So here, x and y are both positive. So everything's positive. In quadrant 2, y is positive. So these two will be positive. And so sine and cosecant, and x is negative. So this one's negative. This one's negative, and then both of these will be negative because I have one positive and one negative. Tangent and cotangent are in quadrant 3, since I have a negative over negative, negative over negative, and then everything else is, so these two become positive because I have 2 negatives and everyone else only has 1 negative, so it's negative and 4. And this is useful for answering questions is like, hi, if I'm in, if I have sine, cosine, and this, what are the trig functions and everything else, then you know what sign to put on and use the terminal angles. Okay. These are things you just probably should have in your back pocket. You used to have to memorize them, but since in COVID-19 time, not so much. Though I'm probably going to reuse these lectures for like years to come. So I mean, once I post them, I'll probably do a flipped classroom and everything. All right, so we've seen this. We've already gone through all this. But we're going to use this to fill out the table. And I want to show you some tricks in order to fill out the table to make your life easier. And I think I already talked about it for this class. Well, let's go ahead and review that. So once again, you should have these inputted into your brain. The sooner you get these inputted into your brain, the easier life becomes, right? For the rest of the course, because we're just going to be doing sines and cosines all the way up until like the last 2 weeks of teaching. So here, remember the little trick I taught you was 0 over 2, 1 over square root 0 over 2, square root 1 over 2, square root 2 over 2, square root 3 over 2, and then square root 4 over 2. Goes up, and then this goes, and then you do the backwards here. So square root 0 over 2, square root 1 over 2, square root 2 over 2, square root 3 over 2, and then square root 4 over 2. And so you can just memorize this, and then once you have that the sign goes from 0 to square root of 0 over 2 and go up by 1 for each of these for pi over 6, pi over 4, pi over 3, and pi over 2. You can get this. Now, is that really what you're going to write? No, what you're really going to write is back up. Really just going to put in 0, a half, square root 2 over 2, square root 3 over 2, and then 1. And then here you'll just do the backwards 1, square root 3 over 2, square root 2 over 2, a half, and 0. Does that make sense? The little trick in order to memorize which way it goes. And then from here, yeah, okay, thanks. I really do appreciate you guys responding in chat. If not, I'm just talking to a wall. All right, so here we can just calculate this. So this over this becomes 0. This over this becomes square root 3 over 3. This over this, so this is 1. This over this becomes square root 2. And then this over this gives us 1 over 0. So this, of course, is, I just put a line, meaning you can't do that. That's what I put. And then cosecant is just the flip of sign. So here, you can't flip that one. Here it'd be 2. If I flip this over, I'll get the square root of 2. If I flip this over, I get 2 square root 3 over 3. If I flip this 1 over, I get 1. Secant and cosecant are just flipped. So here I'll get 1. Here I'll get 2 square root 3 over 3. I'll get square root of 2. I'll get 2, and then I'll get can't do. And then this is just this flip, so I can't flip that over. This will be square root of 3. This will be 1. This will be 3 square root of 3. And this is, of course, 0. So this is just something you need to be able to do and calculate. All right, I'll leave that up for a second, and then I'll move on to the next one. Gee, I'm just kind of plowing through class today. I'm debating to either do the next set of notes today and do a flipped classroom tomorrow, or just call it early after the first set. And I'll cross that bridge when I get there. All right, let's look at this. All right, so we have all these trig functions. So we want to evaluate these trig functions. And so what we're going to use, we're just going to use so we're going to do two things. We're going to use for here, we just write it in directly, right? Here we just have this from we know this from our chart. Our chart says this was a half, and we just put it in directly, okay? The next one over here is 11 pi over 6. Well, 11 pi over 6 isn't on my happy chart from here, right? I got from here, but my reference angle should be, right? So I want to figure out what the reference angle is 11 pi over 6. So reference. So that's why I went all this reference angle stuff. So the reference angle of 11 pi, that looks like pi over 6. So what's the reference angle here? Do you guys know? Pi over 6, yeah, so it's pi over 6. And if you need help, you can always just, for now, you can always just look right here. So here's 11 pi over 6, right? So my reference angle is pi over 6. Notice this is in quadrant 4. And so here, secant of pi over 6. So here we're going to take this. We're going to take there. So secant of pi over 6 is, we'll just look at our little graph. I'm going to do this slowly, and then we'll go faster for the next one. So pi over 6 secant is 2 square root 3 over 2. It's 2 square root 3 over 2. Now, in order to answer my question, we need to go back to this first one. We're in quadrant 4, and secant is positive, and so it's actually the same. So here we can actually say, all right, well, this is 2 square root 3 over 2, so this is going to be 2 square root 3 over 2. So we're not solving these with triangles? Not yet. The way your book runs is we do it all with the unit circle, and then that's chapter 5, and then chapter 6 we do it all again with the right triangles. So that's what we're doing. You can't make this into a right triangle currently because that's bigger than 180 degrees, and so you're like, well, I'm done, right? That's what we teach the reference angle and stuff. For here, I'll do 1 or 2, and then I'll have you guys do 1 or 2. So here for pi over 4, the reference angle here is 0. So it's cosine of 0. Because notice pi over 4 is just if I went around once and then twice. And so this is cosine of 0 is indeed 1. So, oops, not cosine equals 0, cosine of 0 is 1. And then this is the same. Let's do this one. So this is 4 pi over 3. The reference angle here, the reference angle of 4 pi over 3 is pi over 3. And so it should be the sine of pi over 3 is equal to square root 3 over 2. However, notice that pi over 3, or 4 pi over 3, oops, I have this, did I say this backwards? 4 pi over 3. Oops, sorry. I'm sorry. Wrong one. Dyslexia got me. I was like, that's not right. So here we are. So 4 pi over 3 is here. And so it's in quadrant 3. So therefore, sine will be negative. So I want to take the negation of both sides. And so the answer here would be negative square root 3 over 2. And that's how you kind of crunch through all these. Hold on. You guys are probably right. This is square root 3. Yep, this should be over 3. Thank you. Thank you for catching that. Yeah, this is secret. Okay, so go ahead and try E and H on your own, and then give it about then give people about 20 seconds or about a minute or so. So give these a try on your own, and then once you're done with them, I'll ask for E first. I'm going to ask what the reference angle is for E, and then what the answer is for E, and then I'll ask what the reference angle for H is, and what the answer is for H. And go ahead and get rid of the circles and do this so you can see. So give these a try. And if I ask you to try and you get it, say you're printing wrong, you're doing it in pen, and I ask you to give it a try and you get it wrong, just put an X over it and just write what the right answer was, and your notes don't have to be perfect for when you upload them. Let me open up something real quick just for my own sanity. Yo, Hi, Albigo. Oops. All right, so go ahead and post your answers, what you got for E, your reference angle, and then the answer. right, so the reference angle, everyone's getting pi over 6. Which is correct, yeah. So here the reference angle is pi over 6. Notice here that 7 pi over 6, for those keeping track, this is in quadrant 3, so it would be secant will be, or cosecant will be negative, so it should be the negative cosecant of pi over 6, which is equal to the negative value of 2, so minus 2. So this answer here is minus 2. Okay, so what you guys get for H? What's your reference angle here? So here, as long as you have this, you're fine, okay? You could say cosine, if you say cosine or cosecant pi over 6 is equal to 2 and then write negative 2 for up here, you're good. You're 100% fine, okay? But honestly, most of the stuff you'll be graded beyond on the web of science. So however you do your homework is how you're going to do your exams. And that's actually super useful for you guys because exactly what you see and how you type it in your homework, learn how to do that because when you do it on the exams, you will, it's the exact same, just you only get 2 tries and it'll be timed. You only have X amount of time to do it. All right, so everyone here got, so the reference angle here is, I got 0, I got pi over, so for H, you guys are getting pi as a reference angle.
Is it just 7 pi?
Yeah, so 20, yeah, so 21 over 3 pi is equal to 7 pi. And notice 7 pi means you're going over 1, 2, so that's 6 pi. There'd be 7 pi. No, wait a second. I need to go 3 times. 3 times is 6 pi. So this is 2 pi. So 2 pi, 4 pi, 6 pi, and then 7 pi. So my reference angle here is pi. Does that make sense, guys? Yeah, pi is the reference angle. So sine of pi is equal to 0. Because the reference angle, so hold on. The reference angle, hold on. The reference angle here is 0. It's pi. Pi is what the closest angle it is on the unit circle. The reference angle is this angle between this and x. Well, it's 0 because it isn't x, right? Why wouldn't the reference angle be pi over 3? Because this is an even, because this even 3 divides 21 evenly, as in 7. Which is the reference angle is always going to be in the first quadrant? Yes, the reference angle is, we'll just do a quick review on that. The reference angle is the distance to the x-axis, right? So whatever angle to the x-axis, that distance is always going to be less than 90, right? Because I can't be more than 90 degrees from my x-axis. So that's always going to be in the first quadrant. And the reason, because once we know that, we know the values for everything in the first quadrant, and then we just need to translate which actual, or the actual angles here is neither in quadrant 1 or 2 or 3. It's actually on the line between the two. So we know that to be 0. But the reference angle here is 0, right? So here, this reference angle is pi over 6. This reference angle is pi over 4. Since I'm flat against the line, it's 0. Okay? Does that make sense why this one it is what it is? Yes. All right. So here I have sine of pi is 0. Also, sine of 0 is 0. Because that's really the reference angle. So the reference angle here is 7 pi, which is equal to, hold on, this isn't, where's my eraser? Eraser? But actually, I don't have an eraser. We'll just have to do it the old school way. I just have to white all this out. Goodbye. Goodbye. Let me explain this in a way that I don't get anyone confused. Goodbye. Electrocution. Make this bigger. Thank you. Much bigger. There we go. All right, now if I write on the right layer, go back to normal size. Perfect. I said 4. There we go. All right, so 21 pi over 3 is equal to 7 pi. 7 pi has a reference angle of 0. Okay. Sine of 0 is equal to 0. So this is 0. And since it's flat along, the only times reference angles here, notice here, I'm technically not really in quadrant 2 or 3. I'm kind of in between, so you'll just have to know what the values of sine and cosine are for this point, and this point, which are fine. It's either 1 or 0 or non-existent. Okay, so let's just finish these other 3 real quick. I think you're getting the song and dance. Here, we have 5 pi over 4. So 5 pi over 4 on right here. So here's my reference angle, and that's pi over 4. So the reference angle here is pi over 4. This is in quadrant 3. And so tangent's going to stay positive, and so it'll be tangent of pi over 4 equals 1, and so this answer is 1. Here is the cotangent of this. Well, my reference angle is this number. So you just write it from the chart. And so until you have it memorized, just come here. Oh, pi over 6 is square root of 3. Okay. Tangent of 2 pi over 4. Well, 2 pi over 4 is the same as pi over pi over 2.
Over 2.
Yeah. Sorry, it's my little cheat sheet's not the same. So pi over 2, then we just come here, tangent pi over 2. Well, I can't do that, right? And so over here, we're just going to say this is undefined. Undefined. Okay, so this is undefined. To solve all these values, do we just memorize that chart? Yes, that's the best thing to do. Or just post it somewhere, print it out, have it somewhere. It'll just make your life easier. Over time, you'll eventually memorize it because you're just going to do so many problems with it. For some crazy reason, I did not put any of my even or odd or my identities on here. There's a pile of identities in the book. Let me just show you real quick, and then I'll have to chop it out because I'm not allowed to show the book when I post videos. There's a pile of identities here in the book, like these even and odd, the fundamental identities and all this. I usually type them all up, but I didn't. So we're just going to write them on the notes. It'll be fine. Do you need to memorize that for the test? Not necessarily. You always can have papers in front of you. At no point will we not have them available. Does that make sense? I don't know what you have in front of your computer. I don't. You can have anywhere between, Stephen Hawking sitting in a chair next to you to your book, pile of notes. I would have it accessible. It'd be a good idea to memorize it, right? But let's go ahead and just write down the even and odd properties real quick, and I'll explain what they are. So you learned in 126 what an even and odd function was. Basically, if I plug in, and we'll just show you with sine. So sine of minus t, if I plug in sine of minus t, I get out minus sine of t, which makes this what type of function? Do you guys remember? And cosecant will actually work the same way. You guys remember if I plug in negative of a value, I get back the negation of the function that makes it odd. Remember that vaguely? Yeah, vaguely. So it's the odd of that function. So here, if we have cosine of minus t, well, cosine is actually an even function, so this is cosine of t. So secant of t of minus t will give us back secant of t. And then for tangent, since it's 1 over tangent minus t is equal to minus tangent of t, and cotangent does the same thing, equals minus cotangent t. Okay. The other one are your Pythagorean theorems. You probably know one. You may not know the others. So Pythagorean theorems are if you have sine squared of t plus cosine squared t. And notice that when we write this, that sine squared of t does not equal sine of t squared. Basically, if we put the power on the word, not the variable, that means what I really mean to do is sine of t squared if I was being pedantic with my parentheses. So sine of what? T. What am I doing to that? Squaring it. What does this mean? This means sine of, this is not equal sine of t squared. Okay. So where we put the powers matters. So sine squared t plus cosine squared t equals to 1. Notice here, if I divide everything else, if I divide this all by cosine squared t, cosine squared t, cosine squared t, you actually can get the other Pythagorean theorem here. I have 1, I have tangent, so sine over cosine is tangent, squared t, cosine over cosine is 1, equals secant squared t. I can do the same thing again. So this turns into this, right? And then I could do it again if I wanted to with sine, divide by sine, 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 and you'll get 1 plus cotangent squared t equals cosecant squared t. So those are these are the 3 Pythagorean theorems. How you get it, you just divide out 1 and you can get the other 2. And the only other theories I just need to kind of go over real quick are the reciprocals. So it's tangent's the same as sine over cosine, and then cotangent is equal to cosine over sine. Secant is 1 over cosine, and then cosecant, oops, t is equal to 1 over sine of t. And so technically, you only need sine and cosine. Everything else you can just convert over, right? So if you see a tangent, a cotangent, a secant, you can just write it all as sine and cosine. All right. So these are the theorems there in your book. I just forgot to put them on the notes, so we're just going to handwrite them. All right, let's just do this very last thing real quick. We'll do it together. And then this is a super popular one for the exams. Even when we did them online, they just love this question. So let's go over it. Not what I wanted. Boop. All right, so let's do this nice and slowly. So let's pretend cosine of t is 3/5 in quadrant 4. Find the value of all the trigonometric functions of t. All right, so what am I going to do here? Well, the first thing I want to do is I want to find the value of cosine of t and sine of t. Because if I have the value of cosine of t and sine of t, I can figure out everything else, right? From this list, I can just calculate everything else. And so that's what we're going to try to do. So cosine of t, I know what that is. That's 3/5, right? And we're going to find sine of t. Well, I just use my Pythagorean theorem. So sine squared of t plus cosine of t squared t equals 1. Well, I know what cosine of t is, and so I can have sine squared of t is equal, plus Cosine of t is 3/5, so it'd be 3/5 squared equals to 1. Well, from here, I can say sine squared of t plus, like my t's have curves in them, this becomes 9/25 equals to 1. I'm going to solve for sine, so I'll have sine squared of t equals 1 minus 9/25. So sine squared of t is equal to 16/25. Oops. I'm going to take the square root of both sides. All right, so that means sine of t is equal to plus or minus 4/5. Now, which one do I want? Well, I'm in quadrant 4. So in quadrant 4, sine is negative. So sine of t here will just be equal to minus 4/5. Okay, so I know it. So usually when I do this one, they'll just list it out: sine of t, cosine t, tangent t. Then I need cosecant t, secant t, and then cotangent t. All right. We'll just put this in. And this is how it looks in the computer. It's just going to give you a whole list of these things. Cosine of t, we already know. This was given to us 3/5. Sine of t, we calculated. It's minus 4/5. Tangent is just, tangent is equal to sine of t over cosine of t, right? So this is just sine of t over cosine of t. So here I'll have negative 4/5 over negative 3/5, and so here I just get negative 4 over 3, and because the 5s will cancel. Cosecant, well, cosecant is just 1 over sine, right, of t, so that's just going to be negative 5/4. Secant is 1 over cosine of t. This is equal to 5/3. Cotangent is just a flip of cotangent is also equal to 1 over tangent. I don't know if I put that in yet. Just use that. So 1 over tangent. So if this is 4/3, the other one's going to be minus 3/4. Okay. So when you see this problem, what you're going to want to do is figure out either, it's going to give you sine or cosine. Figure out the other one. Figure out the other function from there. Make sure you use what quadrant it is to determine what sign is the correct sign to be. And then after that, you can just use these rules to crunch through the rest of these. All right.